Okay, we're back to 6.2. I ended here at example number 2, where we are finding the volume of the solid whose base is a circle of radius 3, and the cross-section perpendicular to the x-axis are isosceles right triangles with the hypotenuse lying on the base of the circle. So the way I've drawn that is what that would look like. I want you to remember that if you have your x squared plus y squared equals 9, that if you wanted to write this as a function, this would have been y equals the positive square root of 9 minus x squared, and the one below it is y equals the negative square root of 9 minus x squared. We're not going to worry about the one on the bottom, but we are going to look at the one on the top, and I'm going to call these sides that are going to be the same, I'm calling them S, and you can see that this right here, because this is an xy point on that function, this is going to be an x square root of 9 minus x squared point. And so if this is the square root of 9 minus x squared, and I know my picture isn't doing it justice here, but this would also be that. So your hypotenuse is equal to twice the square root of 9 minus x squared. Okay, so that is going to be your hypotenuse there that is along the, going from one side of that circle to the other. And so now, once we know that, we're going to use the Pythagorean theorem. Hypotenuse squared equals side squared plus side squared, okay? And we're going to look for S. The reason why we're looking for S is because we need the area of that triangle, and we know that its area is 1/2 base times height for that triangle. Well, those S's are your base and your height. So if you are, finding the area, you want it in terms of X, but right now you would only be able to use S, which is not a part of what your base is. So we're going to solve this for, oops, I forgot to change my color over again. Sorry about that. But we're going to solve for S here, okay? So if I divide by 2 and then take the square root of both sides, I can see that my S is the square root of 2 times 9 minus x squared. And so once you have that, you can go ahead and finish this 1/2, and then this would be the square root of, oops, sorry, instead of 2, I wrote S. 2 times 9 minus x squared, and that's squared because this is just 1/2 side squared. And so, of course, the square and the square root will go away. So we've got 1/2 times 2 times 9 minus x squared. And, of course, the 2's cancel. And so your S is actually just 9 minus x squared. Or, I'm sorry, not your S. Your area is 9 minus x squared. So what we have been doing, and I'm just going to make this smaller so I can write over here, we have been saying that we'll find the volume by integrating. Now, let's stop here for a second. This is symmetrical, and so if I went from 0 to 3, and then I multiplied that by 2, that would give me the whole volume. So I'm going to use symmetry, and I'm going to multiply by 2 the integral from 0 to 3, and we're going to just integrate that area, okay, the area of the triangle. So what ends up happening is it's just adding up, infinitely many of those. And so our volume is 2 times, and this would be 9x minus 1/3 x cubed from 0 to 3. 2 times 9 times 3 minus 1/3 times 3 to the 3rd, and then of course minus 0 because it has an x in both, so that would end up giving you 0. So 2 times, this is 27 minus 9. 2 times 18, 36 units cubed. Now, had they told you that the side of the isosceles right triangle was lying on the base of the circle, okay? So let me just sketch this real quick. But you've got your circle, and if they would have told us that this right here was the side, okay, that means that it would have gone up like that as another side, and this would have been my hypotenuse, right? And whatever the length here is would have been equivalent to the length here because it was an isosceles right. This would have been a different problem, okay? This side would have been your 2 times the square root of 9 minus x squared. And so when you found your area of your triangle, 1/2, your base would have been 2 times the square root of 9 minus x squared, and your height would have been 2 times the square root of 9 minus x squared, because it was an isosceles right, okay? And if like I said, if they would have said that the base of the circle contained the side and not the hypotenuse, this would have been 2 times 9 minus x squared would have been my area. And that would have been what I was, integrating. And so had you gotten that, had it explained it like that, had you had to write it like that, your answer would have been 72 cubic units, okay? Just the way it's worded and the way you have to read that and draw it is very important for these problems and really kind of difficult to do. Example number 3, let R be the region bounded by the graphs of x equals y squared and x equals 9. Okay, so let's try and sketch this. So here's your x equals y squared, okay? And x equals 9, we're going to put right here, okay? So x equals 9, and this is x equals y squared. Find the volume of the solid that has R as its base, okay? So this right here is my R. That is my base of my solid. And every cross section by a plane perpendicular to the x-axis is a semicircle. Okay, so this time, perpendicular to the x-axis, we have a semicircle coming out of the page. So just tons and tons of semicircles coming out of the page, right? Perpendicular to the x-axis. You're just going to pick one of them, okay? You're just going to pick one. You can see that if this was a point, like an XY point, sorry, my pen doesn't want to write, that this distance right here would be the Y value, okay? And you would have 2 of those. So basically, but this would actually be the radius of your circle, okay? So you really don't need that second one. You just need to see, what is the radius of my circle? Well, this part of it is y equals the square root of x. So your y value is the square root of x. So that means that your r is the square root of x. Okay, so that's going to be the radius. And they're half circles, though. So if we were calculating the area of that half circle, it's going to be 1/2 pi r squared. Well, if my r is the square root of x, this is going to be, because the square root and the square cancel, this is going to be pi x over 2. So if I want to calculate my volume, I would be looking at going from 0 to 9, and my a of x is pi x over 2 dx. So this is going to be pi over 4 x squared from 0 to 9, pi over 4, 9 squared minus pi over 4, 0 squared, 81 pi over 4 units cubed. So that one wasn't too bad. Okay, I think we just have a couple left here, 2 more. So find the volume of the solid whose base is the region bounded by the lines x plus 2y equals 6, x equals 0, and y equals 0. If the cross sections taken perpendicular to the y-axis are equilateral triangles. Okay. So let's go ahead and draw this. I took my x plus 2y equals 6 and I solved it so that I could see what it was linearly. So 1, 2, 3. I know that it crosses the y-axis at positive 3, has a negative 1, positive 2 slope, negative 1, positive 2 slope, negative 1, positive 2 slope. Okay, so that looks like your x plus 2y equals 6. And then, excuse me, x equals 0 is the y-axis. So I'm going to go ahead and draw a line down there so we can see where this region is. So there's my x equals 0. Y equals 0 is my x-axis. And so this right here is the base of your solid. That's the base of your solid. Now, perpendicular to the y-axis are equilateral triangles. Okay, so perpendicular to the y-axis, there's that. And I'm talking about equilateral triangles. So that means that every side is the same. So again, imagine that this is a point on your function, okay? This would actually be the x of your point. So you're talking about this distance right here is going to be the side, because this is going to be side, side, side. So the side is going to be the x of your function. And so if I solved my function for x, this is going to be 6 minus 2y. Now, I haven't said this before, but what you're actually doing when you are integrating, like let's look at the last one that we did, or even this little one that we drew right here. Imagine that instead of just one two-dimensional triangle, let's think of this as a triangular prism that actually has a little bit of a width, okay? So that it's more of a, like, just like a, a brick. But the distance is your delta x, which is actually your dx. So here, when you're thinking of it being sliced and you're slicing it perpendicular to the y-axis, you're imagining that this triangle has a width to it. And that width, like if you kind of made this so that you could see that it was a width, that width is along your y. That's how you knew that you were going to be integrating with respect to y. So you know now that you're going to be going along the y-axis here from 0 to 3, okay? Instead of along the x-axis from 0 to whatever this point would have been. What would it have been? 1, 2, 3, 4, 5, 6 or something. I don't know, maybe 6. But we don't care because we don't need to do that. We're integrating along the y-axis. And so when we build our volume equation, we're going to be integrating from 0 to 3 along the y-axis, and our area, oops, now that's going to be a little bit of work, sorry, because it's 1/2 base times height, right? So when I drop that perpendicular here, I've got 1/2 s and s. So I've got s squared, which is the hypotenuse squared, equals height squared plus, leg squared plus leg squared. So s squared is equal to h squared plus, this is going to be 1/4 s squared. And we're going to say, well, this is 4/4 x squared, and I'm subtracting, that's an s, 1/4 from both sides. So that's going to give me 3/4 s squared is h squared. And then when I take the square root to get my height, because I need that for my 1/2 base times height, because I need the area of my triangle. Because remember, right here is your a of x. I need to put a of y, sorry. I need to put my a of y in there. And so here's my h, okay? Square root of 3 over 2 times s. And so once I get that, I'm like, well, what is my s? My s is 6 minus 2y. So if I'm talking about area 1/2, my base is s, which is 6 minus 2y, times my height is square root of 3 over 2 times s. This is going to be square root of 3 over 4 times s squared. And then to make it in terms of y, we're going to put our 6 minus 2y in. So this is what we're integrating here. The square root of 3 over 4 times 6 minus 2y squared. And so now I'm just going to go like this. Bring that down here. So our volume, I'm going to bring that square root of 3 over 4 out front, integrate from 0 to 3, 6 minus 2y squared dy. Well, this is going to cause me to have to use u substitution. And my du is negative 2 dy. So du over negative 2 is my dy. And if my y was 0, then my u is 6. If my y is 3, my u is 0. Okay, I just did that by putting those values into my u equation right here and solving for my u. And so I've got square root of 3 over 4, integration u squared du over negative 2, and look, where y is 0, I'm putting a 6. Where y is 3, I'm putting a 0. Now, we know that this is going to have to be flipped. And when you flip it, it negates it. So that's going to get rid of this negative sign here. So I've got square root of 3 over 8 now, integral from 0 to 6, u squared du. Okay? And so now, square root of 3 over 8 times 1/3 u cubed from 0 to 6, and I just keep it u. So square root of 3 over 24 times 6 to the 3rd. And 216 times the square root of 3 over 24. Divide by 24, I get 1. Divide by 24, I get 9. And this gives me 9 times the square root of 3 units cubed. Okay? So that one was u integration, but I also want you, this is the beginning of you looking at this volume equation as area of the base times height. So when you're integrating from A to B, or when you're integrating from C to D along Y, not only are you taking the area, but you're imagining that it has a thickness, and so it's times the height. So again, like for my semicircle, we were thinking of it as not only a semicircle, but we were thinking of it with a thickness, right? And oh boy, that's hard for me to draw, but it has a thickness so that there, like that, where your thickness is your delta x, and the area of the base times the thickness is what you're actually adding up. Area of the base times the height. So that does make sense because that is volume. Remember, volume, area of the base times the height. So we took the area of the base times the height of delta x, which, you know, we changed to dx because we're taking infinitely many of them. And so we're just basically adding up all these volumes of these little three-dimensional things. And so it makes sense on this one when we had the equilateral triangle and we said, well, it's actually, you know, has a little bit of a thickness to it. And I know that that's hard to draw, but it has a thickness. And we took area of the base times the height, and that's what we took to get the volume. And so if this one was C to D, we did area of the base with respect to y times the height, and that was our dy. Because really that height goes, you know, it's very thin, infinitely many, they go to 0. The thickness goes to 0. All right, so now let's look at our last example. Example number 5. Let R be the region bounded by the graphs of y equals square root of x and y equals 2 minus the square root of x. Okay, so you've got this as the base of your three-dimensional figure. Find the volume of the solid that has R as its base if every cross-section perpendicular to the y-axis is a rectangle of height 3. Okay. So for this one, it doesn't matter where your rectangle is, but it's always going to have, sorry, I don't know why my pen's going out here. It's going to have a height of 3. So if I drew this rectangle over here, all of them are going to have a height of 3. What's going to change is this right here. This distance right here is going to change because, you know, sometimes it's going to be up here, you know, it might be here, it might be here, you know, so all those different ones, when we add them all up, we have to make sure that we account for each one of them. So, you know, how is this going to affect what we're doing? Because here it's going from, you know, it's going from the x squared to the other side of x squared. But on up here, it's going from the 2 minus x squared to the 2 minus x squared. So we're going to have to do 2 different integrals because it's really using 2 different functions. So an important thing to figure out is, where is this point of intersection? So if I set my x squared equal to my 2x squared, and I, you know, added x squared to both sides, and then divided by 2, and found that my x's are -1 and +1, oops, I can see that those are my x values, but remember, my thickness is along the y-axis. So when I'm adding these up, since it's perpendicular to the y-axis, this is going to be y integration. And so I want to know what these y values are, okay? Because I need to know, you know, I'm going to be going from 0 to this y value with x squared, and I'm going to be going from this y value to 2 with my 2 minus x squared. So if I put 1 in, I get 1 squared. So that means that this is 1 on the y-axis, is where they cross. So this would be the point -1, 1 on this side. This one would be the point 1, 1 on that side. So I know that I'm going to have to split this up into two separate integrals, because on one of them, and if I have y equals x squared and I take the square root of both sides, my x is the square root of y. Because remember, if I picked a point here, and I should probably do it in a different color, but if I picked a point here on my function, it would be an xy point. This distance right here is going to be the x of it. So the x of it is the square root of y. And I've actually got two of those. So this is going to be 2 square roots of y, okay, for my integral from 0 to 1, okay. My area of my rectangle is going to be 2 square root of y times 3. So that's 6 times the square root of y. And I'm going to add the integral from 1 to 2. Now, for that one, again, it would be the x, you know, if I pick this point on my 2 minus x squared, this would be the x of it. And so if I take my y equals 2 minus x squared, and I said, well, I've got y minus 2 equals negative x squared, I've got 2 minus y equals positive x squared, and I took the square root of both sides, this x is going to be the square root of 2 minus y squared. And so I've got 2 of those distances, okay? And then I'm going to find the area of that rectangle is going to be 2 square roots of 2 minus y times 3, because this would be, you know, like your length times your width. And this length is 2 of those x's that I just found. So 2 square roots of 2 minus y times my height of 3. And so this is going to be 6 times the square root of 2 minus y as my area. And so 6 times the square root of 2 minus y dy is going to be the second part of my integral for volume. And so now we are just going to integrate here. And I'm going to go ahead and erase some of this so that I can have some space. I know you guys already got your notes on all this stuff, so I can move it here. My eraser is going way slower than I am. We're going to change it. Oh, it's starting to catch up with me. And you guys can probably, you know, turn this off and try and solve that integral on your own. So I'd bring the 6 out in front, integral from 0 to 1, y to the 1/2 dy, plus bring the 6 out in front, integral from 1 to 2, square root of 2 minus y dy. And so this is going to be y to the 1/2 plus 2/2, which would be y to the 3/2, and then multiply by 2/3 from 0 to 1. And this one, you're going to have to think of it as you use substitution. And your dy is going to have a negative. So if you did use substitution of 2 minus y, du is negative dy. So negative du is your dy. And this is going to be the integral of u to the 1/2 times negative du. And we'd have to say, if my y value is 1, my u would be 1, because I would have 2 minus 1. If my y value is 2, my u would be 0. So I'm going to go from 1 to 0 for u on that one. And what we're going to do is it's going to flip and going to get rid of that negative. So divide by 3, divide by 3. This is going to be 4y to the 3 halves from 0 to 1. And then this is going to be plus 6 integral from 0 to 1 u to the 1/2 du. So 4 times 1 minus 4 times 0 is that one. And then plus 6, this is going to be u to the 1/2 plus 2 halves, which is u to the 3 halves, and then multiplication by 2/3 from 0 to 1. And you don't have to put that stuff back in. Divide by 3, divide by 3. So you've got 4 plus, this is going to be 4u to the 3 halves from 0 to 1. So 4 plus, this is going to be 4 times 1 minus 4 times 0. So this answer